Hello everyone, welcome back to all. So in our last class we discussed about quantum numbers, right? So in this class we are going to discuss about one more important topic and interesting topic, that is structure of atom. So atom. So all of you know very well about atomic structure. And in our previous classes also we studied about what is an atom, what are different atomic models. So let us recollect all those things. So generally all of you know very well about atom. So atom consists of some subatomic particles. So what are those subatomic particles? So electrons, protons and neutrons, right? So electrons are negatively charged particles, protons means positively charged particles, neutrons means neutral in charge. And you know very well about protons and neutrons are called nucleons. So these nucleons are present at the center of the atom. So protons and neutrons. And these electrons are revolving around the nucleus. So this is the fundamental knowledge regarding the atom. So the mass of how the atomic mass is determined. So atomic mass means here the electrons having very less mass, very negligible mass. So protons having 1 unit mass, whereas neutrons also having very near to 1 unit protons. So the mass of the neutrons, atomic mass or mass number, is denoted with capital A, and mass number is equals to number of protons plus number of neutrons. And what is atomic number? So atomic number is denoted with capital Z. So atomic number means number of protons is equals to number of electrons. So atomic number is capital Z. So all these are fundamental topics relating to atom. And all the atoms are neutral in state. So now before going to study about the structure of atom, means atomic structure, there are different models are there. Rutherford's model, J.J. Thomson model, and Niels Bohr model, Sommerfeld models, like this. So before going to explain all those topics, we have to know one more important topic, that is spectrum. Have you ever heard about this? What is a spectrum? Do you know anyone? So this is very important topic. So get ready. If you take a prism, for example, this is a prism. When you incident any white light on this prism, this is a white light. So when you incident a white light on the prism, what happened? This white light will be split into different lines. Okay, so this is called spectrum. These white light will be split into 7 different colors. So that is called Webezier. So this Webezier means this is a one kind of spectrum. Best example for spectrum is rainbow. So rainbow is the natural spectrum. So in this white color will be split into 7 colors. So V means violet, I means indigo color, blue color, green color, yellow color, O means orange, and R means red color. So all these 7 different colors is called spectrum. Best example is rainbow. So rainbow is a natural spectrum, all of you know. And one more point here, And this spectrum is a continuous spectrum. Very important point. See, when you observe the rainbow, all the 7 colors, for example, this is the rainbow. In this rainbow, all 7 colors are looking like a continuous spectrum because one color is merged into another color. Means we can't distinguish all the colors separately. Each color is merged with the another color. So that is why rainbow is a continuous spectrum. So this is the spectrum. Now let us see one more topic. Wave nature of light. So generally light having two types of natures. One is particle nature and second one is wave nature. And now in this class we are going to discuss about the wave nature of light. How the light waves are formed and how it is determined. Let us see. For example, when you throw a stone, for example, this is a pond. If you throw one small stone into this pond, what happened? So in this pond there is a water is there. There is a disturbance is created by throwing a stone into this pond. Then the water is transmitted or propagation in the form of a wave. So this is called water wave. So the water wave will be in this way. So this is called water wave. And this water wave is in the direction of this way. So here take one more example. For example, when something is vibrating, for example like a drum, if it is vibrating, what happened? Then sound waves are produced here. How the sound waves are produced? Like this. So the sound waves will be like this. So these are called sound waves. So this is the direction of the propagation of the sound wave. So what is the difference? So what is the difference between these two waves? So these water waves are called transverse waves. These sound waves are called longitudinal waves. So in the water wave, this upper part is called crust and this part is called trough. Crust, crust, trough, crust, trough, crust, trough, like this. So in this sound wave, some particles very closer to each other. So this is called compression. And here some particles are far away. So these are called rarefaction. So in the sound wave, longitudinal wave, there are compressions and rarefactions. Compressions, rarefactions. Compressions, rarefactions are present. So now let us see what is the difference between the transverse waves and longitudinal waves. So in transverse waves, so this is the wave and the vibration of the particles in water wave or transverse wave are perpendicular to the propagation of the wave, which means the particles vibrating in this wave are perpendicular to the direction of the propagation of the wave. But in case of longitudinal waves, the particles vibrating or moving are parallel to the direction of the propagation of the wave. So this is the difference between transverse wave and longitudinal waves. Here crust and troughs are formed. In this longitudinal wave, compressions and rarefactions are formed. So these are two types of waves. Now let us see how the light waves are formed. For example, take a charged particle. What is a charged particle? For example, electron. So electron means it is containing negative charge. Proton means positive charge. So all these are charged particles. So this type of any charged particle is vibrating continuously. Then what happened? Then electromagnetic waves are produced. Electromagnetic waves means nothing but light waves. How the electromagnetic waves are produced, ma'am? Let us see. This charged particle is moving continuously. Because of this continuous vibrating, what happens? There is a change in the electric field. So this is the electric field. So this is the direction of the propagation of the wave. So this is the electric field. So because of the continuous vibration of these charged particles, there is a change in the electric field. So varying electric field is there. Because of the change in this electric field, there is a change in the magnetic field also there. So this is called magnetic field. Is it okay? So this is magnetic field. So because of this change in the electric field, magnetic field is formed, and because of change in the magnetic field, electric field is formed. So this is electric field, this is magnetic field. Electric field, magnetic field. So like this process is continuously going on. So because the charged particle is vibration continuously, there is a change in the electric field is formed. Because of change in this electric field, magnetic field is formed. So like this, the electromagnetic waves are produced. The electromagnetic waves are nothing but light waves. Okay, very important point. And here we have to remember one more important point, that is, so electromagnetic waves, so this is the electric field. This is electric field, okay? And here this is the magnetic field, which means what did you observe here? Means this electric field and magnetic field both are perpendicular to each other. This electric field and magnetic field, electric field and magnetic field. These two fields are perpendicular to each other. And also one more important point. And these two fields are perpendicular to the direction of the propagation of the wave also. See, these two fields are perpendicular to each other and also perpendicular to the direction of the propagation of the wave. See, this is the direction. For example, if you take this is x-axis, this is y-axis and z-axis. Or this is z-axis, this is x and y. Means the two waves, electric wave, electric field and magnetic field, both are perpendicular to each other, in the same way perpendicular to the direction of the light also. So this is nothing but the electromagnetic wave or light wave. Here we have to observe one more point. What is the speed of this wave? See, in case of water waves or sound waves, these two waves are called mechanical waves because they require a medium. Without a medium, the wave cannot be propagated. Some medium is required for these waves, but this electromagnetic wave is different. It doesn't require any medium, which means the light waves can travel through the vacuum also. And in vacuum, the speed of the light wave is very high. So the speed of the light wave can be c is equals to, it is represented with c, velocity is 3 into 10 power 8 meter per second. So this is the very important value you have to remember. What is the velocity of the electromagnetic wave? 3 into 10 power 8 meter per second. So this is the velocity or speed of the visible light. So this is electromagnetic wave. Now let us see what are the characteristics which are affecting the electromagnetic wave, important characteristics. So there are two important characteristics are there. Electromagnetic wave. So the first one is called wavelength. So wavelength means, for example, take a wave. This is a wave. So in this wave, this is the direction of the propagation of the wave. So this is called crest trough, crest trough, crest trough, like this. So here the distance between the two successive crest or two successive trough, so the distance is called wavelength. It is denoted with the letter lambda. So wavelength is represented with lambda, the distance between any two successive crest or trough, or you can take any two successive compressions or rarefractions also. So that is called wavelength. So generally units of wavelength, so this is the length, that is why it is expressed in angstrom units and nanometer units also. Generally 1 angstrom value is equals to 10 power minus 8 centimeters or 10 power minus 10 meters. So this is the angstrom value. In the same way, 1 nanometer is equals to 10 to the power of minus 7 centimeters or 10 to the power of minus 9 meters. So this is the wavelength. So you have to remember the units also and the wavelength. Now let us see the second characteristics. So the second one is called frequency. What is a frequency? Generally frequency is denoted with nu. Frequency means nothing but it is inverse of time, which means, for example, the number of wave peaks that pass by a given point of time, given point per unit time. So the definition is very important. For example, if you give the time is given 1 second, in this second how many wave peaks are passing the given point? So that is called frequency. Frequency is denoted with nu, which means it is inverse of time. So units are second inverse or hertz. So Hz it is represented with. In the same way CPS means cycles per second. So this is also units for frequency. So these are the very important factors or characteristics for electromagnetic wave. Now let us see one more important point. Relation between nu and lambda means frequency and wavelength. So the frequency the wavelength is inversely proportional to frequency, which means if wavelength is increases, what happen? Frequency decreases. If wavelength is decreases, frequency increases, means it is inversely proportional. If the wavelength is longer, means there is the lower frequency is there for any wave. So this is the relation between frequency and wavelength. Now let us see one more relation between frequency, wavelength, frequency and velocity of light. So there is a relation between these three. C is equals to nu lambda. So this is very important relation, you have to remember. C means velocity of light, nu means frequency here, lambda means wavelength. So how it is? For example, speed. So speed C is equals to, what is the definitions for speed? Generally distance by time. Okay, distance means here lambda, time means 1 by nu, so which implies nu lambda. So C is equals to nu lambda. This is the very important relation. And here you have to remember one more important point. Can we apply this equation only light waves? No. This is not a this is a universal relation between all the three quantities. So you can apply this relation to any waves, light waves or sound waves or water waves, whatever it may be. So C is equals to nu lambda. So we have discussed what is the wave nature of light. In the same way, what are the electromagnetic waves and the characteristics affecting the electromagnetic wave. Now we have to learn about one more important topic, that is electromagnetic spectrum. So this is also one more important topic. What is an electromagnetic spectrum? So see, we are discussing about light waves, electromagnetic waves. There are a number of electromagnetic waves are there. Each wave can having a different wavelength. So electromagnetic spectrum means, so electromagnetic waves can have a wide variety of frequencies. Is it clear? So each wave having different wavelength. There are a number of waves are there. So the entire range of the electromagnetic waves is called electromagnetic spectrum. Which means there are a number of electromagnetic waves are there. Different waves having different wavelengths and frequencies. So the entire range of this electromagnetic wave is called electromagnetic spectrum. So to explain this electromagnetic spectrum, I will show one diagram. Please wait. So see, this is the this is the electromagnetic spectrum. So this is electromagnetic spectrum containing different waves. So here first cosmic waves are there, gamma rays, X-rays, ultraviolet rays. In between VIBGR is there. This is VIBGR, visible spectrum, and infrared rays, microwaves, radar waves, radio waves, and broadcast band. So the electromagnetic spectrum consists of a continuous range of wavelengths from shorter wavelength gamma rays to and longer wavelengths radio waves, which means here gamma rays containing shorter wavelength, whereas radio waves containing higher wavelength. So here only the wave is in this way. See, the wave is started in this way, like this way, which means, so this is the shorter wavelength. So this is the longer wavelength. So here gamma rays are there, gamma rays, and here radio waves are there. See, here we have to observe one more point. If wavelength is shorter means higher is the frequency. Very important point you have to remember. See, if shorter wavelength means the rays may containing higher frequency. Higher frequency means they are highly energetic rays. That is why these cosmic rays, gamma rays, X-rays and ultraviolet rays are very harmful to us. They are containing very high energetic, high radiation. So that is why these rays are containing very high frequency. Whereas infrared rays, microwaves, radar waves, radio waves and broadcast band, all these are containing very lower energy. Okay, this is electromagnetic spectrum. So in between the ultraviolet rays and infrared rays, there is a spectrum is there. So this is called visible spectrum. So very important, let us see. Visible spectrum means our eye can only sensible to this spectrum only, which means this visible spectrum generally obtaining from 400 nanometers to 700 nanometers wavelength only. Very important. So if lower the 400 nanometers and higher the 700 nanometers, our eye can't see. Our eye only sensible to see from 400 nanometers to 700 nanometers only. So that is why this is called visible spectrum. And here you have to remember one more point here. This visible spectrum is generally containing 7 colors. So violet color, indigo color, VIBGYOR. See, violet, indigo, blue, green, yellow, orange and red color. So this is red color, orange color, yellow color, green color, blue color, indigo color, violet color. So this is VIBGYOR. So in this, it is extended from 400 to 700. So here the violet color is containing shorter wavelength. This is shorter wavelength. Whereas red color containing higher wavelength. Which means the violet color containing shorter wavelength means higher frequency. Frequency is very high, which means higher energy. Whereas red color is containing higher wavelength means shorter frequency. Shorter frequency means shorter energy, less energy is there. So this is all about the electromagnetic spectrum as well as the visible spectrum. So now let us see what are the electromagnetic spectrum region, how the wavelengths are expanded. So generally gamma rays, X-rays, ultraviolet rays, VIBGYOR, visible spectrum, and infrared rays, microwaves and radio waves. So these are the main rays in the electromagnetic spectrum. The wavelength is generally gamma rays containing 0.001 nanometers to 0.01 nanometer. So X-rays are from 0.01 nanometers to 10 nanometers. So ultraviolet rays are from 10 nanometers to 400 nanometers. So VIBGYOR is from 400 nanometers to 700 nanometers. So infrared rays are from 700 nanometers to 1000 nanometers. So microwaves are 1000 to 10 meters. And radio waves are from 10 meters to 100 kilometers. So these are the region of wavelengths for electromagnetic waves. So only we can see the visible region only. So this value is very important. In which region the VIBGYOR or visible spectrum may exist? You may be asked a question in this way. So this is from 400 nanometers to 700 nanometers. So this is all about the electromagnetic spectrum as well as the visible spectrum. Now here one question is there. So one question you may be asked in your exam in this way. For example, what happened? Very important question. When you heat an iron rod. So this is a question in your textbook. So what happened when you heat an iron rod? So take an iron rod. So this is the iron rod. If you heat this iron rod with the help of a furnace, so what happened? So when you give some flame, some heat to this rod, what happened? The iron rod is first absorbing heat. So some of this energy is emitted in the form of light. First light will come. Then what happened? First the iron rod will be appeared into red color. If you raise the temperature, if you increase the temperature, what happened? So this energy, red color, is converted into, if you increase the temperature continuously, then it will convert into orange color. Then after yellow color. Then after blue color. And finally white color also. Why it is happening all the colors? Means, see here, the red color means, already we discussed red color containing higher wavelength and shorter energy or frequency. So first we are giving a shorter amount of little amount of energy, that is why first red color will appear. If you increase the temperature means, then what happened? Then frequency is increasing. So in VIBGR already we discussed that red color containing lower energy, violet color containing higher energy. So that is why then if the temperature is increasing, it converts into red to orange and orange to yellow, yellow to green, green to blue, and finally indigo and violet also. And I told that white color also will come. Means white color means sometimes here visible all wavelengths also. White color means it is a combination of 7 colors, right? So sometimes here all colors also will come. If you see here the temperature is very low. If you see here, the temperature is somewhat high. At this point the temperature is very high, but the end of the iron rod it will appear in black color only, because there is no heat here, no temperature is given to the end parts of the iron rod. At the center of the iron rod only the temperature is very high. So that is why it converts its colors, because of the increasing of its temperature. So this is all about today's class. So once again I will tell all those things. In this class today we discussed about spectrum and wave nature of light, what is the electromagnetic wave and what are its characteristics, and what about electromagnetic spectrum, and how the wavelengths are there for electromagnetic waves, different waves, and finally what is visible spectrum. So this is all about today class, and in next class we will continue this topic. And if you want more videos from us, please like, share and subscribe my channel. Thank you.